Alright, in this video we're reviewing statistics and we'll touch on something new called standard deviation. So to calculate the mean of a data set like this, chips in Pringle cans, we have to add up all the numbers and then divide by the total number of cans we looked at. So just on a calculator, hit the fraction button there, you can start typing 86 plus, you add them all up like that, and we go down and divide by 10 because there were 10 cans that we were looking at. So the mean, if we hit S to D, is 89.7. Mode is the most frequently occurring number. There are 2 times where 93 shows up, and everything else is just 1 time. So that's our mode. Sometimes you might have 2 modes, sometimes you might not have a mode at all. It just depends on the data set. Now to work out these are called the 5-number summary. We have to put the data in order. So essentially what you do is you start from the lowest numbers, so 82, and you cross off all the numbers and you sort of write them in. So I think our next lowest one is 84, and you continue that process. All right, once we get our data all in order, there is our minimum and there is our maximum. So we can pop these 2 in. So we've got 82 and we've got 98. Median is right in the middle. So I like to sort of go in one at a time. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So the median is actually in the middle of these 2 numbers. When that happens, you just take the average of those 2 numbers. So you get 90.5 for your median there. Q1 and Q3, you basically do that same process just with the first half and the last half of the data. So for Q1, you cross them off from that middle point in. So that number there will be Q1, which is 86. And similarly, Q3 is in the middle of that last half, so it's 93. Just like that. If you want, the median is sometimes called Q2, so it makes a nice little pattern there. We can get the range. So essentially the range, you just do the max minus the min to get that. And for the interquartile range, it's Q3, take Q1. So we look at the max minus min, that's 98, take 82, so 16. Interquartile range is 93, take 86, so that's going to be 7. Okay, now we got these new concepts called standard deviation. There is a way to work it out by hand, but I'm going to show you how to find all these numbers on your calculator, including standard deviation. So basically you just go into the normal menu here, hit menu to get back to the front page and go statistics. You want to clear out any data you might have already had in lists here, and then we want to enter the data. You can actually just enter the original list of data, you don't need to put it in order. So I'll do that, and we'll go and we'll enter like 86 for the first one, 82 for the second one, 91, 93, 98, 84, 92, 93, 90, and 88. And then we should have 10 things, which we do. You want to hit F2 for calc, and then you want to hit the set button. Now, this one here can change. Now, it depends what type of data you have, but basically if you have a frequency list like this, this option should be list and then 2, and you'll sort of write 2 lists in that front menu here, kind of looking like what that one looks like. Since we've got our Pringles data and it's just a big long list of numbers, we just hit F1 to put 1 in that option there. So yeah, basically because we've got a big long list of numbers, we're putting 1 in for this option. Hit exit and then just hit 1 var on the calculator, and that should give you all these. So a few things, X bar is just the mean, so X with the bar over the top. So that's the 89.7 number that we got there. Don't worry too much about all this stuff here. If we scroll down, we'll see those numbers we got before, 82, 86, 90.5, 93, and 98. So you'll never actually have to find these by hand. You can always just do it on the calculator. And mod is the mode, that's 93. And I don't think the calculator tells you range and interquartile range, but you can get that pretty easily. Anyway, these 2 numbers, sigma x is the population, so that's 4.54 for the population. And sx is the sample standard deviation, 4.78. Okay. So if we're talking about the Pringles cans, I definitely want to use this one, and I don't want to use population. This would be if I had every Pringles can in the universe. If I have every single one, I'm allowed to use that number down there. This top number is for if you just have a sample. Now, last time I checked, there were more than 10 cans of Pringles in the universe, so we just have a sample of cans here. So that's the correct number to use. And the way that you can interpret standard deviation is it means how spread out is the data. So big standard deviation means that it's very spread out, and a small standard deviation means that it's very condensed together. So if all of these had like 84, 84, 84, 84, 84, the standard deviation would basically be 0. These two numbers here, range and interquartile range, also tell you how spread out the data is. So between these three, you can basically figure out how spread out your data is. If you ever do want to calculate the standard deviation by hand, you're in for a rough time. Here's the formula. It's pretty rough. So basically, apologies about the blurriness there. You add up each data point, you take away the mean, and then you divide by n take 1. And this big sum sign means add all those up. So that's for the sample standard deviation. So if we were going to do our calculation here, we would do that entire thing there. And you can hopefully see the way that I've done this is that number there, 82, that is our first data point, and that is our mean. And then you square it. And then you do the next data point and take away the mean and square it. And you literally add all those up. And then you're dividing by n take 1 in this case, which is 9, because there were 10 cans. N take 1 is 9. If you want the population standard deviation, you're just dividing by n instead of n take 1. That's the only difference. So one thing I should mention is this mean here, x bar is the sample mean. And if you see the symbol mu, it's the population mean. So if we had every Pringles can ever, we'd be using the mu symbol. And since we only have a sample, we're using x bar. Similar for standard deviation, the sample standard deviation we just call S, and the population we call sigma. And that's really summarized in this table here. So keep that in mind for notation purposes. There's also something called the variance, which is just the standard deviation squared. Last thing we're going to do is just make a box plot. So draw a box plot of the data. I might just copy down our 5-number summary that we got here, and we're going to draw a box plot of this. Now you absolutely can do box plots on your calculator. You can hit graph, set, go down to where it says whatever it says there, go across, change it to med box, and then exit out and hit graph 1. And that should give you a picture of a box plot here. But we'll draw it by hand. You can draw box plots either horizontally or vertically. Just because you've seen a horizontal one on the calculator, I might draw mine vertically. It doesn't really matter. So we got to put our scale on there. I'm going to do the little squiggly line, which means we're going to start a little bit later. And we might start at 80. And what are we going to go up to? 98. So we'll go 80 there. I'm going to go 85, 90, 95, 100. And these are chips. So that's the number of chips in a Pringles can. And then basically minimum is 82. So you'll pop in your minimum there. Should be roughly there. That's the min on the box plot. Q1 was at 86. So we're just going to draw a little bit of a wider bit at 86. The median was at 90.5. So the median goes in the middle of the box plot there. Q3 was at 93. And then the maximum was at 98. So you can connect those up to draw a lovely box plot. You can also mark your mean. Sometimes you mark your mean 89.7 on the box plot. So whereas 89.7 there we go. So yeah, that's somewhat what a box plot can look like. So you put the max there, Q3, you put the median, Q1, and the min.